it as arrays. And what are the operations? How do you operate with the different like addition, subtraction, or maybe matrix product and transpose, trace of the matrix. Next, what is the properties of the matrices like transpose, determinant, inverse, adjoint matrix. Next, uh, then if suppose if you'd like to generate the matrices with all zeros, all ones, or a random matrix like a dummy matrix, how you can generate with any dimension if you want. It's like 100 by 100, 10 by 10, whatever the size of the matrix, how do you generate? Or otherwise, suppose linear system of equations. How do you solve a linear system of equations using the matrix? What syntax is available in MATLAB? How easily you can be solve this? And what are the different ways and how you can get it? Next, the factorization, LU factorization, QR factorization, singular value decomposition. How do you get those matrices here using the MATLAB software? Next, how do you find characteristic polynomial, eigenvalues, eigenvectors, eigenspaces with respect to certain eigenvalues? So these today I planned. Today's session is it is just like a hands-on completely. That's why I request the participant you start with your virtual MATLAB software. You start with virtual MATLAB software. Hope the screen is visible.
Yes, sir. Screen is visible, sir. Too, sir. Thank you.
See, in between, suppose when while you are practicing, anything is not getting, you can message. Is my voice low?
No, sir. No, sir.
Yeah,
The message was previous one, sir.
yeah, fine, fine. See, for these, I would like to take, this is the second day session. I would like to take the new live script, or if you want to type in command window, you can type the command window also. Nothing wrong. I am planning to take the new live script. Even if this option is available in your virtual MATLAB software, you can take the new live script. The top left, there is an icon, new live script. Once click on this, it is opening like this. Now first arrays. So I planned here. So first matrices and arrays. How do you generate row matrix, column matrix, or simply the vector, column vector, rectangular matrix, square matrix? What are the operations? So these we will practice now. First arrays. So always the matrices can be generated within the square bracket only. Always the matrices can be considered within the square brackets only. That is the grammar of MATLAB for the matrices. Now suppose only row vector with 3 columns. Suppose 1, 2, 3. Just give the space or give comma. You can give the space in between the element or give comma. But don't give both. That means for first one comma, next one is space. Don't give like that. You can give either one. Both will give the same result. You can see here 1, 2, 3. You just control enter. Over the keyboard, you just press it, Control Enter, or otherwise there is a run button here. You can just click on here. Just click on Control Enter. Here, run section or run. Either one you can use. There are three different ways. Next, similarly, suppose if you want to generate the column matrix within the square brackets only, but how you separate the row by row, that is by column. I'm generating only column. So first one is only row matrix. Of course, you know what is the meaning of this percentile. These can be used to comment what we are typing it. Now this is column matrix. Suppose 2, 3, 4, 5. How many rows you want to generate? It's just like see here 1, 2, 3, 4, 5. Now suppose you want to generate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 10 or maybe up to 100. How you can generate those? Generating elements. A is equal to 1 to 100. You can see here. Just click here. We'll get to know what about the 1 to 100. You just pass through this like this. We'll get to know 1 to 100. This is like this. Or only up to 10 you want to generate it. 1 to 10. Like with the space or step size you'd like to generate. That means suppose B is equal to 1 to 10, but you want to generate with 0.2 step size or 0.5 step size. See here, we are using just colon, 2 dots. And here you can observe, first one is, let me give the syntax here. What is the syntax? Starting value, step size, and end value. This is the syntax. You can generate from 0 to 1, 1 to 2, 1 to 3, whatever it may be, but the step size is 0.2. Now you can see because the step size is 0.5, 1, 1.5, 2, 2.5, 3, 3.54 like that. So this is creating vectors. These are creating vectors. So you can create with any step size. So any doubt means you just ask me for creating this. With step size one means no need to give the step size. By default, you can give what is the starting value and ending value. This is the start and end. By default, spaced with 1. By default, spaced with 1. One step size, if you are not assigning any step size for this case. Just take 0.1. You can see suppose 0, 0.1, 1. like that. You practice with any. So not getting any doubt. So that means everyone is executing correctly. Now there is another way of creating the vectors. This is with step size, right? Now I would like to create a vector from 1 to, or maybe 0 to 1, either one, with 15 subintervals. In B getting 1.52. I'm not understood your doubt, Jayanti.
You can ask directly.
Hello, sir.
Yeah, yeah.
Sir, I'm getting as 1, 1.5, adding 0.5 to the 1. Like that till 10 I'm getting, sir.
Yeah, that is only 0.5 only difference, right?
But are you getting here 8.59? That
No, no, no. That will be there. You just, once you click on the output, it will show the down arrow. Then you can drag it. You can see here, you can drag this.
yes, sir, yes, sir. Yes.
Yeah.
Yes, sir. Thank you.
Because that space is not enough, right? You can drag it, then it will show like this. Or
Okay.
otherwise, there itself, it will show the drag bar. You click on the drag bar and you can move left and right. That will show the complete values. Yeah. Now, next, creating a vector from 0 to 1 with 15 subintervals. Earlier, we are not defining how many subintervals, but for that, what it will be? Linspace. That means linearly defining that the starting point, ending point, and how many number of intervals you are dividing. Let me give the syntax. Start, end, number of partitions. Number of partitions. You just click it, then it will show. See, you can see 1 into 15. The output C is 1 into 15. So 0. The step size by default it will take according to generate the 15 elements. You can see only 10. Then observe what you'll get. Or you can take 100. In between 0 to 100. Or 20 or 30. Like that you can try. So these the different ways of creating vectors.
Sir, a small doubt, sir.
Yes, please.
Sir, you have said that from 0 to 1 with 0 to 10 with step size 1 means it will take its own interval or depending upon the equal subinterval, sir?
No, equal subintervals only.
Equal only, equal only. If we don't want equal subintervals, if you remove that, it will take randomly, sir. Is there any random position?
You mean if we remove 10?
10.
I don't think it is. Yeah, it's by default it is taking 0.01.
Yeah. That means I'm saying that from starting and ending point you are giving, and we are giving what is the step length it is getting.
No,
If
no.
you want
Here we are not defining the step length. We want how many elements in between. That's all.
okay, only
Including
how many
endpoints.
Okay, sir.
So including endpoints, total how many points you are expecting, accordingly you need to give. So this is linear space syntax. But the
Okay.
step size indication, this is the syntax.
Okay, sir. Thank you.
If you would like to specify what is the step size means, you would like to take this.
Okay, sir.
But I don't want any step size, but total these many points I want in between means, so you have to give this. Yeah. So I'm just breaking the section, Control Alt Enter. Or otherwise, you can see here there is a section break beside the run. There is a section break. Just go to the end of the cell and I'm taking the next cell. Why unnecessarily confusing all in a single cell? So that's why I'm just taking the one more cell. Or if you want, you can continue the same.
So how have you taken the cell, sir?
You can see here the top there is a run. Beside the run there is a section break.
Okay,
There you
sir.
can break the section. See, if you want the different alignment, that means immediate after input you want to see the output, you can see the right side there are different alignments. Layout of this complete live script. First one is left input, right output. The second one is immediately whatever the input and what is the output of that. The third one is differently. Only output it is showing. Okay, so whichever you comfort that you can take. There is no restriction. Immediate after input you want output, or maybe only output, or the left is input and right is output. So whichever you want, you can take the layout of this live script. Now I'm generating rectangular or square matrices. Suppose a 2 by 2, 1 space 2, next row can be separated with colon, 3 and 4. You can see. So 2 by 2 matrix, the right side. You can generate the rectangular matrix also. It is like 1, 2, 3, 4, 5, 1, 2 by 3 matrix. You can generate any size of the matrix, the square or rectangular. I don't think you will get a doubt here. You can easily type it. But if you want to suppress this, you don't want to execute these as output. So you can suppress with at the end putting the colon. This is at the end you put the colon, then that output will not be given. So this output will not be printed. Usually sometimes the people, even for what you are expecting the output, at the end you type the colon and you are looking why it is wrong, why the output is not coming. So that means this is the reason. If you remove this, then the matrix A will be appeared. So let me take the same size of the matrices, 3 by 3, 3, 4, 5, 6, 7, 8, 9. I'm just taking 3 by 3 matrix for A, and similarly for B, 1, 0, 1, 2, 1, 5. Just randomly I'm taking this. These are A and B. Operations on matrices. Addition, I'm just taking ADD. Just for my convenience, I'm taking this variable ADD, A plus B. Addition of the matrices. The size must be same, A and B. Is right? You can see addition of the corresponding elements of both matrices. Similarly, subtraction A minus B, matrix product A star B, element multiplication. You tell me what is the difference of these two, the first one, second multiplication, the first and second multiplication difference.
Each element of matrix A is multiplied with each element of matrix B.
Yeah, with the dot means element by element product. That is why I mentioned E multiplication for our convenience. LHS, you can give any name. Left to the is equal to, that is a dummy variable. You can give any. Is no need to type what I'm using, the same A, DDS, UB, MUL, EMUL, like that. You can use any of your choice according to your convenient. See, suppose I'll change simply A, but the answer never change. That means this is the dummy variable. You can use any name in place of that. So dot star is nothing but element by element product. Now suppose power multiplication, if you want to give A square, you can see what will get A square. That means A star A. Okay. But you can see this A dot cap 2. What the difference of these two? The second one is element by element square of the matrix A. See, this is the matrix A, right? Now first element 1 square is 1 only, 2 square is 4, 3 square is 9, like that. A dot cap square means element by element square. Or only A square is nothing but power of the matrix. So that means A into A, like that. Taking the matrix product of A twice, or you can give 3, 4, 5, like that. So just another power, but you can see matrix product A power 1 by 2. A power 1 by 2 I'm giving. That means not only for integer powers, any real power of the matrix, how you can find. So this is A power 1 by 2, like this. You can give any value of power.
Sir, a small doubt, sir.
Yes.
Here, A power 1 by 2 means what it represents, sir? What will it do, sir?
Square root of the matrix.
Square root of the matrix.
Yes, square root of the matrix.
Actually, A square means according to the matrix multiplication, we go first row, first column, first row, second column, like that. Here, how can we go for A power 1 by 2?
A power 1, just power of the matrix I'm finding, A square. In place of A square, place of the square I'm taking 1 by 2.
Okay.
EMUL, why it is needed? No, this LHS is not mandatory. You can use anything. Okay, dot star B, right? See, this is the option. According to what need it is, then you can use it. I'm giving the information. I'm not sure where you can use and for what this can be applied. We don't know, different participants need the different options, right? So that's why I'm giving all options. Dot star means element by element product. That's all. No, I gave, see, this is the product, right? I gave a separate name. That's all. These LHCs, it is just like whatever the name, if you want, you can give. There is no specific meaning of left to 2 is equal to. Don't worry about this. Okay, real power. I'll give real power of the multiplication just for our understanding. That's all.
Sir,
Yes.
sir, PMUL ante have you taken as a power 2, right, sir?
Yes.
A
Power.
square, A square.
Yeah.
EPMUL means A
L,
dot power 2. What it difference?
no dot cap, right? Element by
Sir.
element product. Here, A power square is nothing but A star A. Okay. But here, A suffix ij, where element by element. Element by element square. A square means. You see what is the matrix A? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? But what you are getting A dot cap square 1, 4, 9, 16, 25, 36. That means element by element square you are getting. Let me take this. I think you will understand now. You can see here what is the matrix A. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Now element by element product means you are getting 1, 2 square, 3 square, 4 square, 5 square, 6 square, 7 square, 8 square, 9 square, element by element square. But here A cap square means A star A, the product of the matrix with itself. That is the meaning of this A cap square. So this is operations of the matrices. Such multiplication is permitted means uh, element by element product. It's simply I'm not sure. Maybe suppose in binary language it may be used, or maybe in digital discrete systems, any system with the discrete elements. There, if you want to make it, then you can use it. We don't know where it can be used exactly. Maybe in technical field, the people can be used the square of the every element. Any system you convert in terms of a matrix. Suppose you double that system, that means element by element product is required. It is not like taking a matrix of product of the matrix with another product. Maybe only the same element you can square it, then you will get. We don't know the what applications of that exactly. Next, suppose this is the matrix 1, 2, 3, 4, 5, 6. I would like to add one more. So new matrix A is equal to what we can do. A of I will add one more column to the end. What will give? Suppose 1, 2, 3. Sorry. Yeah. You just add one more. That's all. Whatever the matrix A, I'm just adding 1, 2, 3 at the end. NA is nothing but revised matrix A. That's all. I'm just giving the another name. That's all. whatever the matrix A, for that I'm adding one more column. This is called concatenation. If I am using star, it is showing error. You check what the size of the matrices in between the star. Left and right of the star, is the size of the matrices compatible or not? Matrix product is not possible for every size of the matrices.
I have taken 2 by 3 only, sir, both the sides. But it
But
is
2 by 3 product is not possible, right? 2 by 3 and 2 by 3.
3 by 3. Okay.
If suppose you'd like to add, this is column wise we edited here. We added the column. Now suppose you'd like to add the row of the matrix A. Maybe at the end, A colon 1, 2, 3. Whatever the matrix A, at the end it is created. We are just clubbing the matrices with another row and another column, that's all. Or suppose any two matrices you want to club it. Suppose let me take A and B. So what is AB? I'll just give A, B. Both matrices you can see. A and B. We are not taking the addition. We are just clubbing the matrices A and B, that's all, one after another. Or if you want to add it after, then it will show like this. It is just like a different alignment of the matrices. Clubbing the matrices one after the another in row wise or in column wise. I'll give both row wise addition, row AB and column AB. That means column wise you can add it. Yes. Row wise adding, column wise adding AB. These are just like a different operations. Adding different matrices in a single matrix is nothing but concatenation. Usually, to find argument matrix to solve linear system of equations, we need to add coefficient matrix and constant matrix, right? So if that is the case, this concatenation can be useful. Let me write here. This concept is called concatenation. We are simply adding column or row, or maybe adding two matrices in row wise and in column wise. Okay. Now the functions of matrices.
Sir, a small doubt, sir.
Yes, please.
Sir, addition, you have done addition of a row or a column. How
No,
to
no.
remove?
This is not. Sorry. Once again.
You have added a new row or a new column by arranging some sentence, that is A of 1 comma 2 comma 3, A of 1
Yeah.
colon 3 colon 3. That means a
Okay.
new row or column is getting added. How to
Okay.
remove a existing row or a column already in the matrix?
I'll give that next.
Okay. Okay.
That is extracting and removing submatrices.
Yes, sir. Yes, sir.
I'll give that.
Okay.
Now the functions of matrices. If you'd like to find e power the matrix, e power the matrix, or sign of the matrix A, or square root of the matrix A, we have already seen a power 1 by 2. Sign of the matrix A, or log of the matrix. These nothing but the functions of matrices. You can take exponential log absolute matrix of A, or in previous session we have seen what are the different inbuilt functions. You can try all of these functions. You can try log of the matrix, log 10 of the matrix, semi-logarithm of the matrix, anti-logarithm of the matrix. All options are available. I'll just take here, this is functions of matrices. You try any, if suppose not getting, just message.
So this is not only for square matrix, that is exist for rectangular matrix also, sir, these functions.
Yeah. It can be not only for square matrix.
Okay, sir.
Next, standard matrices like zero matrix, matrix with all zeros, matrix with all ones. For any matrix, what is the lower triangular, upper triangular, and what is a diagonal matrix? How do you extract it? How do you generate random matrix, magic matrix, identity and size of the matrix? How you are going to find? So let me take the same. So this is, now let me know the standard matrices. Suppose you'd like to know what is the size of the matrix A. You can see the LHS. I'm not giving the space. If you give the space left to is equal to, it won't be executed. It will take it as this is one variable, and because of the space, A is also another variable. That means you are expecting two different outputs. One can be stored in size variable, another can be stored in A variable. That is why we can make it like this. We don't take the hyphen. If you take the hyphen also, you can see there is a underline. But if you take underline, underscore, then it won't be. Now size of the A. This is the syntax to find the size of the matrix. SIZE. Or you can take a length. You can take length of the matrix. You can take either of the syntax. Size of the matrix. What is the size of the matrix? 3 by 3. Next, generating zeros matrix. Zero matrix. So this is the syntax. Zeros of what size you are expecting. See, if you want to give only square matrix, means you can give only 5, only one element. If you want to generate matrix with all elements 0, and this is a square matrix, means you can give only 5 or 5 comma 5. Both will give the same result. If suppose a rectangular matrix, it is just like 3 comma 5, 3 rows and 5 columns. You have to specify how many rows and how many columns. So this is a different way. It is generation of matrix with all elements are 0. Next, all elements with 1. Just for my convenience, I am taking a different notation here. You take any notation if you want. Now the M1, all elements, you take 10 by 10 or 100 by 100 also you can try. Just try. We are not writing manually, right? You take any. someone raised the question why we need to take 5. You take anything. See, if you want to take here 15, you take 15. That many columns you will get. There is no restriction of only 5 or only 3. You see this one, it is showing 100 by 100 matrix. It's giving 100 by 100 matrix. Even only with 1, you will get only 1. 1 is equal to 1. Or only with 5. Or suppose if you want to generate rectangular matrix, 5 by 7, you'll get differently, 5 by 7. This is a matrix with all zeros and all ones. Next, random matrix. Random matrix. Random of 3. 3 by 3 matrix. I don't think every people will get the same result. You can see. Random of 3. Just simply generating any random matrix. We are not particularly expecting certain element in rows and columns. Randomly, it will give the values. For every execution, it will give a different result. Random of 3 or maybe any size. See, once again, I'm executing it. It is showing different result. Again, I'm executing. Again, it is showing different result. Again, I'm executing. It is showing different result. For every execution, it will give the different matrix. That is why random. Randomly, it will give the values, element values.
Sir, every time it executing, it is changing, but the
Yes.
phenomenon is same. That is 0.39, 0.65. Can we keep natural numbers like that? Only 1, 2, 3 like that randomly, without points. Can we get?
You mean decimals?
Yeah, in decimals.
Only integers you are expecting.
Yeah, like that. Is there any function?
No, there is no function. It just randomly, because you are expecting integers means that is not random, right?
Yeah.
That is a biased matrix.
Okay.
It will give any value and it will give.
Okay, sir.
All entries are 4 means what you do, you take these, what size you are expecting. The participant Vidhi is asking if we take all entries or some constant, for example, all entries are 4, then how we can write? It's very simple. This is, I'll just give once, suppose 4 by 4 matrix or maybe 5 by 5 matrix, right? You multiply with 4, that's all. You multiply with 4.
Okay,
You
that
create a
means
matrix
first we
with
have to
all ones,
generate
then
identity
multiply with
matrix.
4.
First identity matrix we have to generate, so that after getting required element, we have to multiply.
Yeah, whichever you want, you can create it using this.
Okay.
Next, identity matrix or unit matrix. This is EYE. You see, except the diagonal, remaining all 0, diagonal elements are all equal to 1. Identity matrix, this is. You can generate any size of the identity matrix. Any size of the identity matrix. But don't create with rectangular. There is no rectangular identity matrix. Identity matrix is always square matrix. Don't try with a rectangular and don't ask me, sir, it is showing error. Identity is always square matrix. Yeah. Now, so we know what is the matrix A, right? I would like to find out what the lower triangular elements of these. What the lower triangular elements of these. We'll just give LA. This is lower triangular elements of the matrix. 1, 5, 9, 4, 8, 7. So above the diagonal elements are 0. That is called lower triangular. TRI. This is the syntax for that. Lower triangular matrix. Next, upper triangular, suppose. Upper triangular matrix A. You just, in place of L, you can use U. Upper triangular matrix. Lower triangular and upper triangular. But you want to know only diagonal elements. Diagonal of the matrix A. This is. What are the diagonal elements of the matrix? Remaining all 0 for diagonal. But if you want to generate like this, you just try. I'm not sure. Just giving say. But see, suppose you know diagonal elements. It is just like you know diagonal elements 1, 2, 3. This is the different. How you generate diagonal matrix remaining all zeros. How to enter upper and lower triangular matrices. Sir, this is lower triangular and upper triangular. How to display diagonal matrix. This is how do you display the diagonal matrix. You specify only the diagonal elements within a square bracket like this. Then you can generate the diagonal matrix like this. So I don't think you are getting doubts regarding lower triangular, upper triangular, diagonal elements and generation of the diagonal matrix. Or you can see here, you can do like this, diagonal of DA, suppose. You will get same. DA means we are taking only diagonal elements. Again, diagonal matrix of the elements 1, 5, 9, it is showing the same. See, we can't, whatever this MATLAB supports, accordingly we can write what we are thinking in mind. MATLAB doesn't give. According to its grammar, we need to give the input, then it will give the output. So these standard matrices. Next, properties of matrices like transpose. How do you find trace of the matrix? Determinant, adjoint, inverse. Now let us see. So any doubt in this? Operations and standard matrices. No. Okay. Now properties of the matrix. Transpose. How do you find transpose? So the syntax for transpose of the matrix. Yeah. Transpose of the matrix. Or simply you can give one more syntax for the transpose, just one quotes beside the enter button in the keyboard, there is one quote symbol. You can use that. That is also you can use for the transpose. Usually what we use the notation for the transpose when you write manually, you can use the same symbol. This option is available in the keyboard just beside left to enter button. You can use either one, trace of the matrix. Next, determinant of the matrix. So only DET is the syntax. This is the syntax to find the determinant of the matrix. In one step, you will get what is the determinant of the matrix A. It's almost zero. The value is approximately zero. That is why it's showing like that. Suppose you take B. To see what you are getting. Determinant of the matrix B. Next, suppose you'd like to find trace of the matrix A. The syntax to find the trace. So trace of the matrix means sum of the diagonal elements. Sum of the diagonal elements. You can see 159, addition of 159, 15. Trace of the matrix, determinant, transpose of the matrix. Next, adjoint of the matrix. This is the syntax to find the adjoint of the matrix. You see, first and third column are same. Even the second column, which is multiple of the first and third one, I don't think inverse will get for this. Because determinant is getting 0, right? You can see this is the syntax to find the inverse. You observe here, matrix is close to singular. Even though it is giving a result. That is, I don't know whether we will consider it as advantage or disadvantage. Numerically, it will give. MATLAB is purely for numerical. That is why it will give a nearest value. For this case, even though it is a singular means a determinant 0. Usually determinant 0 means there is no inverse. Yeah, you can generate Hermitian, skew Hermitian, whether the given matrix, simply you type A is equal to A transpose, is it true or not? That you can try. Yeah, complex matrices are also can be found. I'll give the example for that. See, you can see the inverse of the matrix B. It will give the result, general result. It is not showing any error. Is right? But if you try inverse of the matrix A, because determinant of A is almost 0, 10 power minus 16 it is showing. So that means the determinant is 0. That is why the inverse is not giving exactly. It is showing some error. Matrix is close to singular, it is showing. But for B, determinant is not 0. Determinant of the matrix B is 4 only. That is why its inverse getting easily. So someone raised the complex matrices, right? Yeah, so complex matrices. You can give 1 plus 2i 2 colon 2 plus 3i and 4 plus 1i. Somewhere else it is showing error, right? Sorry. Yeah. You can generate like this complex matrix. You can find the conjugate also. So conjugate of the matrix. Just simply I replace by minus I. That's one. That is why it's showing. Yeah. So how do you find rank of the matrix? Rank of the matrix A. This is rank of the matrix 2. That is why determinant is 0. Actually, size of the matrix A is 3, but rank is 2 means determinant is 0. That is why inverse is not getting same. There are the syntaxes. Let me check the internet. I'm not sure exactly. Conjugate of complex matrix. C transpose. Complex conjugate transpose. So directly you can find C transpose for the complex conjugate of this. For this you are asking, right? Yeah. For CA, suppose you want to find a complex conjugate. Conjugate of the matrix CA. You can see this is the syntax. Conjugate of the matrix CA. 1 plus 2i, here 1 minus 2i. 2 plus 0i and 2 plus 3i, 2 minus 3i. Now suppose you'd like to find out system of linear equations. Let me show you, for example, these are system of linear equations. I think it's visible, right? Yeah, fine. Now you can see this system of equations. You just take any matrix, any system. You can see the first one A, the problem one, 20x plus y minus 2z is equal to 17, 3x plus 20y minus z is equal to 18. How you can solve using this MATLAB? Let me take the concept is solving system of linear equations. Solving system of linear equations. Usually we know this is the syntax. Ax is equal to b, right? So let us take what is A here. Coefficient matrix 21 minus 12. First row. Sorry, minus 2. Second row 3, 20 minus 1. Third row 2 minus 3, 20. This is the coefficient matrix. And what is B? Right hand side. Constant matrix. 17 minus 18, 25. Colon minus 18, colon 25. This is. These are A and B. So I'm not executing A. If you want, see, this is A and B. I don't know where it is showing here. RAB, CA, it is showing error. Maybe the matrix is replaced. Okay. So let us take the different notation for this coefficient matrix. Okay. So coefficient matrix AC, just BC. I'm taking the different notation. That is why it is not showing. This is matrix, coefficient matrix and constant matrix. But how do you find solution of this? X is equal to what it means? X is equal to inverse of A into B. Is right? You can see matrix is close to singular. Matrix is close to singular. Oh, sorry. We need to take AC. Yeah. So this is the solution. Finding inverse of the matrix. So this is X, but what is the solution here? Solution is nothing but X is equal to inverse of the matrix A into B. So that is why simply we are taking this. But this formula can be useful only if the coefficient matrix is non-singular. Otherwise, it's not possible to find the solution. And you can use row reduced echelon form concept. Row reduced echelon form concept for this. Let me show you all in one. Yeah, let me take the section break here and let me copy all these things for your convenience. Yeah. Now you can see this is the coefficient matrix, constant matrix. This is one way of finding solution. And using row reduced echelon form, you can see here RREF of, you need to take AC and BC. That means augmented matrix. You can see this. Now these augmented matrix you can convert into system of equations. X is equal to 1, Y is equal to -1, Z is equal to 1, like that. Whichever you want, you can take. It shows consistent or inconsistent. That means we need to write a code. If rank of augmented is equal to rank of coefficient matrix, then it will give. For that, we have to use a conditional operations. That is why I didn't plan to explain here. When we try to discuss conditional formats or looping formats, I'll explain what you are discussing, the consistent and inconsistent. How do you verify? Don't mind, you remind me that day. I'll explain the same when we discuss about the conditional if and else if. At that time I'll explain you.
Okay, sir. Okay,
Now,
sir.
yeah. So this is R or EF. Or suppose if you want to find directly what is the solution of this, there is another syntax: linear solve. Linear solve A, C, coefficient matrix and constant matrix. Directly it will give the solution. So these are the three different ways of finding the solution for system of linear equations. One is using the inverse or row reduced echelon form or linear solve. There are three different syntaxes. Okay, now let us see what is submatrices. So you know what is the matrix A? 1, 2, 3, 4, 5, 6, 7, 8, 9. But I need to know that what is the element in second row, second column. What is the element in the matrix A? You can see here I comma J. In which row, which column element you want to know that. That you can see like this: second row, second column element. That is 5 only. But these 5 you would like to replace. Suppose you type 10 by 10 matrix. You came to know that one element by mistake you typed. How do you replace that element? That 5 you can replace like this. Second row, second column element is a 5, but by mistake we typed 5 in place of 1. That you can replace it. Now you can see that 5 is replaced with 1. You can extract what is that element, or you can know that what is that element. Why it is showing 1 means just now we created the matrix A. That is why it is showing 1 only. Even if you type A, you can see that 5 doesn't show here. Only 1 it will show. Just now we edited that. Like that, suppose second row, third element, what is that? Third row, second element, what is that? Let me type first what is A, then you can easily get to know what is meaning of that A remaining. Yes. Second row, third element, third row, second element, like that. Suppose you want to take the submatrix 1, 2, 4, 1. Want to take the submatrix 1, 2, 4, 1. Submatrix. Submatrix of A. How you can take? So 1, 2, 4, 1. 1, 2, 4, 1 elements. First row, second row, first column, second column, right? That is why the rows we can make like this. You can see 1 to 2 is nothing but first row and second row it will take. Comma. Next we are taking in place of the columns 1 colon 2. That means first column, second column. Now you can see 1, 2, 4, 1. You will get it. Or only 7, 8 you would like to execute. Only 7, 8. So in matrix A, third row, first and second column, right? So 7, 8 you can execute. Extracting differently. This is called extracting the matrices. One of the participant asked, how do you remove certain columns or elements, right? So this is the way. Suppose actually the matrix A is a square matrix, right? 3 by 3 matrix. But you can see here we are getting only 2 by 2 matrix. We are just extracting like this. This is how you can execute it.
Okay, sir. Okay.
Raksha, one of the participant is asking homogeneous system of equations. Yes. Does it give only trivial solution? Yes, it will give trivial solution. Not always trivial, sometimes non-trivial also. So how do you replace any by mistake typed element or maybe rows or columns or certain elements? So this is the way of extracting submatrices and replacing those. Even see, you are getting 7, 8, right? That 7, 8 you can replace with 1, 1. You can see what matrix will get. 7, 8 is replaced with 1, 1. Or complete square matrix if you want to replace. Actually, that is 1, 2, 4, 1, right? Let me replace that with identity 2. That means 1, 0, 0, 0. You can see that. I'm sorry. This is LHS is already given, right? Yeah. Let me remove that. Yes. You can see here 1, 0, 0, 1. Let me take in different. Yeah. I am replacing here. Don't confuse with this. Yes. How can we write Gauss-Jordan form? Gauss-Seidel, Gauss-Jordan form. For that, conditional and looping operations are required. We will discuss that time supports in further sessions. How can use for probability matrix? That means a transient matrix, I think.
Sir,
Yes, yes, ma'am.
sir, here SA have defined as A of 1 is to 1 colon 2 like that, right? What
Yes,
is
yes.
the means, sir? 1 is
Uh,
1 colon 2.
1 colon 2 means from first row to second row. And this is columns also from first column to second column. See, suppose I'll replace with 3. What it will give? SEA. You can see what it is showing in SEA. 3 columns are showing, 2 rows and 3 columns, right? That means 1 to 2, first to third column. 1 to 2 means first row to second row, like that. See, for these, the practice is required submatrices to understand what exactly it is. You try with different alignment, then you understand what operations can be used for different, especially these indices operations plays an important role in coding for any computational techniques. Next, the last one as what we planned, finding eigenvalues and eigenvectors. Eigenvectors. See, for the matrix A, simply this is the syntax, EIG of A. But it is showing only eigenvalues, right? But we want eigenvectors also. So for that, also the same syntax, but you see these LHS, we are giving a different outputs. Okay. So we will give values. That means in second, we'll give values. these will give vectors. See, the 10 is eigenvalue. For that 10 eigenvalue, first column is corresponding eigenvector. 1 is eigenvalue. For that eigenvalue, eigenvector is second column. 0 is eigenvalue. For that eigenvalue, eigenvector is a third column. So that is how we need to take here what is eigenvalue and eigenvector of this. Eigenvalue and eigenvector of this. See, particularly for 10, you want eigenspace. So then eigenspace of the matrix for eigenvalue 10. You can see what you will get. Only eigenvalues. Or directly with these syntax, you can find about eigenvalues and eigenvectors. So, okay, so this is what we planned today, the second session, matrix operations. How do you create vectors, arrays, matrices? What are the properties? How do you generate the standard matrix, system of equations, and properties of matrices like inverse, trace, determinant, rank, inverse, even suppose system of linear equations, how do you finding eigenvalues and eigenvectors? So these what we planned and I explained. And the tomorrow session, we are going to discuss about how to plot the functions and what are the different alignments, styles, how do you label the curve, and how you can draw multiple curves in a single window or maybe different window. That we'll discuss in tomorrow's session. So any doubt means you can ask.
Actually, sir,
Yes, sir, please.
so this is certificate course.
Sir?
So this is certificate course. We'll get certificate after this course.
Sir, you ask the
Yes, sir.
organizers.
Sir,
For
sir,
any
please just-
content questions, you can ask.
Okay.
Okay.
Participants, please
The
ask any
solution
doubts
space
regarding
will
the
come,
subject.
sir.
One by one, please. Yes, madam.
Can I ask, sir?
Yes, madam.
Sir, can we get that solution space?
I mean, you mean eigenspace, right?
Yes, sir, eigenspace.
Yeah, it is there. You just Google it, eigenspace in MATLAB, you will get the syntax. I just tried it now, right?
Yeah, here have you shown eigenvectors?
Yes.
What that means, sir, I'm not getting that vectors. We are getting 3 by 3 matrix over there.
Okay. So here you can see the values is nothing but whatever the diagonal elements. Values is also showing in a matrix form, right?
Sir.
Diagonal elements are eigenvalues. 10, 1, 0. These are the eigenvalues. For the eigenvalue 10, what is the eigenvector means? In vectors, it is showing 3 by 3 matrix. The first column is eigenvector of 10. Second column is eigenvector of 1. Third column is eigenvector of 0.
Okay, like model matrix, sir. It is showing model.
Exactly. You are right, madam. It
Okay,
is
sir.
just like model matrix. Say any more?
All the participants, if you have any doubts and queries, you can ask now regarding the subject. Other than subject, you can contact me. I will explain you. Sir is waiting. If any doubts, you can ask now only. Actually, sir said that for this regarding like Gauss elimination, Gauss Jordan like that, they are related to condition. On day 4, if sir started if else and if while looping, at that time sir will explain the Gauss elimination, Gauss Jordan. Yes, sir. Am I right?
Yes, sir. Yes, sir. Correct.
Yes, sir. Yes, sir. Thank you. Okay, I think, sir, will you teach up optimization tool? So one I have asked a question in chat box.
Will you teach us optimization tools? I'm not sure, sir. The time supports.
Yeah.
But you can
Actually,
contact
depends
me
upon
after,
session.
you can contact me after the course. Sir will
Okay.
give the contact details.
Actually, the session will go according to the schedule. If the
Yeah,
time
yeah.
persists, after time persists, sir will explain whatever you need. Okay, thank you, sir, for your valuable speech today.
Yes, sir. Yes.
I think I also learned so much, sir. Today, for this session, my guru, Professor S. Vijay Kumar Verma, also joined, sir.
Oh, good, sir. Thank you,
SV is
sir.
seated, sir.
Sir, namaste. Good afternoon. Verma, sir.
I think he has been known, sir. He has
Okay,
been known.
okay, okay.
Okay, thank
Fine,
you very
fine.
much, sir.
Okay.
Okay, you can. Hello, participants. So actually, while explaining, some of them are asking doubts. That is, I will clear now. What is that? While using that e mulp and mulp node, that is, it is just for our reference. That is what before the comment is that is a star b means that is it is for multiplication. For that multiplication, SAR is writing LHS to understand ourselves in a general manner. That is the explanation. So that is not a particular rule. We can use anything, whatever we want, comment section. Okay. So don't worry. Please note your doubts and please let me message me whatever you have doubts. At the free time, I will discuss, sir, and arrange. And also one extra day, if possible, I will ask. Otherwise, we will discuss with another one. Okay. Thank you. Thank you, everyone. We'll meet tomorrow. Don't forget to attend exact at 3 p.m. tomorrow also. Thank you.